Isaac, how are you doing?
I'm okay.
Esther, are you okay? Esther, can I hear you say hi or you wave? Probably show your presence on the chat.
Hi, everyone.
Good. What about Laura?
Good afternoon.
I see Laura, you are there. Meanwhile, we also have Kyle. Kyle, you also there?
Good afternoon.
Well, you must say you're most welcome. I don't know how many of you were able to finish up that assignment on Unit 1, or according to the new curriculum, we call it chapter, the first chapter. Who has started doing the assignment? Introduction, we already did finish looking at the introduction, where we basically had to look at the concept of physics, defined physics, and then alongside which we had to look at the concept of the laboratory. Now, at the end of the unit there's that assignment that was supposed to attempt. There's that assignment that was supposed to attempt. I don't know how many people have tried, but according to, I've only, I think, Kyle, you were able to submit. I got a notification from Kyle. Isaac, are you finding some challenges?
No, I can access the work.
Okay. So have you started attempting the assignment?
Yes.
And then Esther?
Yes.
Mm-hmm. Which unit are you currently on? That you attempting?
Yes. Pardon?
Are you done with the first chapter?
Not yet.
Okay. So what about Laura?
At first, I couldn't access the work, but they have just helped me out today.
Okay. That is okay. Now, if you're able to access, I think that is fine. So you'll be able to submit just your work when you're done with that unit. And your assignment for that unit, I'll be able to mark it, then you'll be able to get your feedback. We have the next unit that we're going to look at. As I try to connect my PC here, having some issues of network. So who's on laptop? Is there anyone of you who's logged in and is on laptop? Is there anyone of you who's logged in and is on laptop? So that I could allow you to share for us your screen on chapter 2 or unit 2, measurements.
I am logged in on a laptop.
I think could you share your screen? Well, you come to you're on history. This is history. You go, you go back and then you right there, search for history, search for physics, search for physics. Then you start course. Yes, you come to measurements after what is physics on your left. On the left, after the yellow highlighting, the second chapter. This one, measurements in physics. Yes, go there. Good. Then could you scroll down a bit? There, this is stop there. I hope the rest are seeing what this has for us there. I was going to say I'm working around my network issues here, so soon when I finalize, I'll be able to join. I'll share my screen. Can you put? Can you change that mode? Can you put light mode? Light mode. You forgot. Anyway, you just leave now there. Just leave there. Yes. Yes. Good. I think this is now fine. At least there, things are now being, the things are very clear. So all of us can be able to see. Yes. Yeah. That is where we're going. That's where we're going. You scroll down. This is just the introduction part to what we're actually going to look at in this chapter. By the end of this chapter, you'll have got those concepts, or we should have looked at those concepts. The first one, you stop there. Estimating, measuring fundamental or basic quantities. We have derived quantities, vectors, and scalars. Concept of SI units. So I'll have to look at the concept of significant figures, scientific method of solving problems, density, relative density, purity, floating, sinking, and to end that chapter, it will be actually ocean currents. So which you see right down there. As we are going to look into this, we shall start by looking at the concept of estimation and measurement. You know, when you go and try to buy something, usually, see, the concept of estimation and measurement, we apply it in life, but it is mainly when you try to go and buy or you're trying to give someone something. See, like here, we know if we're to do that, if Kyle is to give something for Esther, Kyle will have to estimate, you will have to measure. Do you have any application of where you see the concept of estimation and measurement being applied, especially at your home station there? Uh-huh. You could stop your screen here now. Allow me to try to connect mine. Yes. So at your station at home, in the station you have there at home, where do you always think you apply the knowledge of estimation, and where do you usually apply the knowledge of estimation and measurement? Uh-huh. Where do you apply the knowledge of estimation and measurement? Isaac.
When you are going to like buy maize flour,
Mm-hmm.
or when you're buying beans.
When you are buying maize flour or when you're buying beans. Uh-huh. That is true. Any other? And any other? It is true when you're going to buy maize flour or in the market, or when you're going to buy beans. This concept applies. That's according to Isaac. Any other?
Also when you are in a butchery.
In the butchery. So we are saying that the physical properties of matter, they are classified into two. We'll find that from there, we're saying physical quantities are classified into two. We have the intensive quantities and then the extensive quantities. We can get from our work on the site there that these intensive quantities are the ones that depend on the quantity of matter. And the other time we defined matter. How did we define matter? How did we define matter? Who can remember how we defined matter from chapter 1?
Matter is anything that has mass and occupies space.
Matter is anything that has a mass. And
mass and occupies space.
And occupies space. Correct. You see, now there are those physical quantities. We have those physical quantities that do have, in this case, matter, and in fact, the physical quantities whose value depends on the quantity of matter in them, which means amount of substance in them. It is the one that causes these quantities to vary. Then these kind of quantities are referred to as extensive. Their value is dependent on the amount of matter, so they are called extensive quantities. Then we have the other type where the value of this does not depend on the matter in them. So these ones are referred to as intensive quantities. So Kyle, you say back, my network is not fine today. I can't connect my laptop. It's trying to load very slow. We have we'll be using what you have there. So we have that now. Because of this, the quantity of matter is actually determined by now the measurements. What determines now the quantity of matter is the measurements. So it is the measurements that determine the quantity of matter. So you continue course. You come to measurements there, which is scroll down to stop there. Stop. That is too much. You only stop on where you see estimation and measurement. So basically, there. Yes. So you can put on light mode. You'll find now that as we try to take measurements or to determine the amount of matter in these physical quantities, we have to do by measurement. So in this chapter, we shall have to learn about how to estimate and measure physical quantities in their standard units and the importance of accurate measurements. So that's basically what we're going to have a look at in this chapter. So I want someone to read for us there the concept, what the big heading there. I mean, what is under that big heading? The estimation thing and the measurements. Who's going to read for us? After estimation and measurements. Kyle, can you read?
Okay. When you go to a butchery, you buy in kilograms. When you are a tailor, your cloth is cut into your size. What is the general term used to describe the above cases?
So that is the situation. When you go to
the butchery,
you buy meat in kilograms, and when you go to a tailor, you cut your clothes according to your size. What term do we generally use to describe this above case or the above cases? How do you buy measurement? Now, when you are there in a home, you might be having 5 members at home, might be having 6 members, you might be even 3 members at home, maybe you might be 10. But you find that in each of these homes, the amount of food that is cooked or the quantity of food that is cooked is not the same. Is that okay? The quantity of food that is cooked is not the same. But how do people get to find a reasonable amount of food or the size of food for the family to be cooked? How is that one usually done? How is that one usually done at home? Esther, how is that one usually done at home? You measure the amount of, for example, maybe if you're trying to heat some water for tea, you measure the amount of water which you're going to heat using maybe a cup. Even sometimes you use it. The container used for heating the water has some measurement on it, isn't it? Or even sometimes what you do is you estimate. You just say, now this is actually now trying to bring us what that unit talks about, estimation and measurement. So in estimation, you are given just a value which is not exact. Is that okay? In estimation, you are given a value, but it is near the exact value by actually making very accurate assumption. Any assumption can be accurate in a way that maybe when there are 3 people here, you can say for these 3 people, let me get the 3 cups of water. So these 3 cups of water, they will be, so that each of them takes a cup of water. You'll find the estimate there as work. You have not what? Measured what these people wanted, but you have just estimated, you see? So that one can be able to work. So there we are estimating. Now, what about measurement? So what do we now do in measurement? See, in measurement, when you now go and buy 1 kilogram of meat, when you now go and buy 1 kilogram of meat, what do these people sell in the meat, the butcher, at the butchery? What do these people use in order to measure for you the 1 kilogram of the meat? What do they use?
A weighing scale.
A weighing scale. Then what is on the weighing scale to make it is having some measurements, isn't it? Some demarcations. Maybe if I can leave alone that, some demarcations. So there are some marks made. These are so many types. If you could just if you could just get to move ahead a bit. When we are to the measuring instruments just below this, there. See, we have those instruments that we use to measure some physical quantities. But those instruments, they have what? Some demarcations. You can see the other one. There's some instrument on the left. And then what is that first instrument, which we have on the left-hand side? What is that instrument? That one is called spring balance. Is that okay?
Yes.
Is that okay? The one next to the spring balance. The one next to the spring balance. That is a measuring cylinder, okay? It's a measuring cylinder.
Okay.
Next, after the measuring cylinder, at least for you, you people, you now know that. Huh? That is thermometer. Huh? That is thermometer. Yes, that one is where the cursor is. It is thermometer. Then next, what is that one there?
A ruler.
Huh? A ruler. Very good. Now let's move to the other instrument there you have in the middle, between ruler and the last one. What is that?
A weighing scale.
That is a weighing scale. So in this case, and then the last one is what we call the stop clock. Last one is what we call the stop clock. So you come to the weighing scale there. See, when you come to the weighing scale, if you want to measure 1 kilogram of meat, on one of the side, there's a standard mass that is put, okay?
Yes.
There's a standard mass that is put on one side, and then your meat is packed on the other pan. On the other pan. So you find that when they now balance at the same level, so you'll say that meat is now 1 kilogram. So that's how they can be able to measure the 1 kilogram. So in that one there, what we're doing is we are using, in all this, what we're doing is we are using a standard mass or a standard quantity to determine the other quantity. So when we come to now, you scroll up where you find scientific measurements, the headings of scientific measurements, scroll up. So, I want someone to read for us what is under scientific methods there, scientific measurements. Scroll down where it is after estimation and measurement. You come scientific measurements here. In this chapter, you come. So let someone read this. Apart from now, Sai. Laura, you can be reading for us that.
Where should I start from?
I beg your pardon?
Where should I start from?
Under, you read other scientific measurements. What is under scientific measurements? And then you stop before that table.
Scientific measurements. In this section, you will learn how to measure some basic physical quantities, length, mass, and time. You'll also learn how to derived physical quantities, that those are volume and density, are obtained from basic physical quantities. Modern scientists use the metric system of units called the Internal System of Units, or SI units, in measurement. Therefore, when measurement of a physical quantity is taken, the quantity must be presented in terms of a numerical value and a unit.
So, see, the key errors here we need to know is, in taking measurements, we need to know about basic physical quantities. So you need to know what these basic physical quantities are. There are some physical quantities which are called now basic quantities, because we did say that physical quantities are actually divided. Quantities are divided into two. We have physical quantities, then we have non-physical quantities. But now these physical quantities are the ones we have in that we're going to look at. So these physical quantities are the ones which can be measured using an instrument and has a numerical value and a unit. So the examples are now what we have as length, time, mass, speed, even volume and density, which is given there. Those are all physical quantities. So we have non-physical quantities which we are not interested in. Some of the examples of non-physical quantities, these are the quantities that you cannot be able to measure using an instrument. I want to have an example here. You have love, you have a feeling, hatred, fear, even anger. Are you able to measure your hatred using some instrument? Which instrument is that measures hatred? So it is a non-physical quantity. That's okay. So these physical quantities are now divided into two. They're now divided into one, the fundamental, which is sometimes called the basic or base quantities, and derived quantities. Physical quantities are divided into two, the fundamental, base quantities, or the basic quantities and derived quantities. Well, these fundamental quantities are the ones that cannot be expressed in terms of other quantities using any mathematical means. So you find you cannot in any way derive or get these quantities from any other using any mathematical means. The examples are now what we have been given: their mass, length, time. But we have others that include electric current, amount of substance, even temperature. But now the derived quantities are the ones which are easily expressed in terms of the fundamental quantities. So which means they are obtained from the fundamental quantities. When you now go to that example of density, uh, we said the density is a quantity that is obtained from other quantities. Formula of density, who can remember what, how we can be able to find density from primary? How did you calculate density from primary? Uh-huh. Christabel.
Yes,
How
teacher.
how do you calculate density? Mass over volume. Mass divided by volume. So you see those two. Mass is another, is one quantity. Volume is another quantity. So which means we're obtaining density from. We're obtaining density from other quantities. When you come to area, how do you get area? Area is obtained using square units, isn't it? We can say, how do you get the area of a rectangle? Laura, how do you get the area of a rectangle?
You get the area of a rectangle by multiplying the length times the width.
You see, we are now multiplying length by the width. So those are two different dimensions. So the two dimensions are, those are they are derived from what? Length. The area is a derived quantity from length, where we have two lengths. The width is a length. The length itself is even a length. So a width is just a description of a term used to describe a length. So we usually define width as the shorter length of maybe you can say a rectangle, and then the longer one is described as the length. So it is a derived quantity. So from there, we now have a description of physical quantities into that. But in measurement here, there's that metric system of measurements which is recommended in physics, which we now say is called the SI unit, where we derive now the unit. This SI unit is derived from the first very basic unit of the mass, which is not mass, but of length, which is the meters, for kilogram, which is for mass, then seconds, which is for time. So being units for the basic quantities, said meter is for length, mass is for kilogram, and I mean for mass is kilogram, then seconds there is for now the time respectively. We can be able to measure our physical quantities. So these physical quantities are now measured using their instrument, but these physical quantities, they have their, first of all, units, they have their abbreviations, or we call sometimes simples, and then the instruments that we commonly use. But you find that when you come to, this will be, Laura will be the one reading this. When you now come to modern scientists there, I want you to read it once again. Modern scientists use. Laura, are you there? So we're saying modern scientists use the metric system of units called the international. So this international system of units, which is called the SI units in measurement, is accepted everywhere. It is internationally accepted. So which means when I measure meat here in Rwanda it is 1 kilogram, and I go to Kampala, this should also still be 1 kilogram. When I go to another part, the calibration I've made on this machine for measuring this mass should also be 1 kilogram. So we shall now say that you have been able to assemble that machine so that it is used in the international system of units. It is scientifically accepted. So our 1 kilogram here mass is elsewhere also 1 kilogram, simply because we are following the international system of units. So now modern scientists use the metric system there in measurements. So therefore, when you're measuring a physical quantity, the quantity must be presented in terms of the numerical value and the unit. So the numerical value is now, maybe if it is, when we say 1 kilogram, in 1 kilogram, what is the numerical value there? We're taking an example of 1 kilogram. If it is 1 kilogram, what is the numerical value in 1 kilogram? Esther, what is the numerical value in that 1 kilogram? Kylie, I think you're trying to talk.
Yes, I think it's 1,000 grams.
It is 1,000 grams. But the numerical value there in 1 kilogram is 1. The one we're looking at, the figure, numerical value is that figure which is attached to the unit. Of course, now the unit is the kilogram. Is that okay? So for this measurement, we do have those two. There should be the numerical value and the unit, unless it is for ratios. And now you can see that we shall be winding up with that table. So be winding up with that table, summarizing actually with that table, because that will be follow with that part. On that table, you can see there's a physical quantity, the name of the unit, and the abbreviation, and the instrument we use for measuring. Let's start with what is we shall be moving in that order. The order we shall start by Isaac. You'll start and you take us through the first two. Read exactly what is there. Is that okay? Then this will be followed by Christabel. Isaac, you start. This is followed by Christabel. Then we shall move to Kyle as number 3, Laura and Esther in that order.
Excuse me,
Then,
teacher, I've been having some problems this side. Why are we going to be reading?
is that Isaac?
Yes, it's Isaac.
So maybe we move to who was the next person after Isaac?
Teacher, it's me.
So Isaac, you watch what she's going to say.
Teacher, me too, I did not understand.
Hey, maybe let me now go through this.
Teacher, network is breaking.
Is it breaking with everyone?
No.
Christabel, are you fine?
Yeah, I'm
is your
fine.
network okay?
Yes?
Esther, is your network okay? Esther has network issues. Kyle, I think yours is okay.
Yes, it is.
Yeah, because for you are the one sharing for us there on the screen, your screen. Laura, what about yours?
Beg your pardon?
What about, is your network okay?
Yes, it is.
Good. Now, I'm going over the first 2 points, the first 2 areas on that table. I will expect each person to actually be picking one and say something about. The first physical quantity that we're having is mass. Are we all seeing that?
Yes.
The
Yes.
first physical quantity is mass. The name of the SI unit, that is the SI unit, okay? The unit that we're considering is the SI unit. The name of the SI unit is kilogram. The correct spelling of kilogram is small k, and then I think those ones follow there. It starts with a small letter K, and then the abbreviation or the simple is small k and small g, kilogram. I know how you can be. Do you know the difference between small k and capital K?
Yes.
Who doesn't? Who doesn't know the difference between small k and capital K? So that I tell you. So which means all of you, okay, you know the difference between small k and capital K. The instrument we commonly use for measuring mass is beam balance. We use beam balance. But we are going to look at each of these quantities you see here, one after the other. So look at them one after the other into details. In this unit or in this chapter, you have these ones covered one after the other. We're going to understand fully what it is all about. Next, we have length. Length is the next unit. Is the next physical quantity. Its SI unit is meter. Its SI unit is meter. It is small m. It is just as it is written there, meter. Then the abbreviation is also what you see in there. For measuring it, we use a meter rule. Length is measured commonly in the laboratory. What was seen as the instruments here are what we commonly see in the laboratory. Is that okay? What we commonly use in the laboratory to measure those physical quantities. So we use the meter rule to measure length. Well, let's go to time. Let's go to time. Who's taking us to time?
Time. Name of the unit, second. Second. Abbreviation, S. Instrument, stop clock.
What type of S is the symbol of the abbreviation?
The small s.
Very good. Next person.
Me. Temperature. Name of unit is Kelvin, and the abbreviation is a capital K, and the instrument is a thermometer.
Correct. We have the next person also. Who's following? Laura, your network was okay. Now you can follow and read for us the next.
Physical quantity, area, name of unit, square meter, abbreviation, small letter m squared, instrument, spring balance.
Is that true?
Sorry, the instrument is not given.
We do not have a specific instrument for measuring area actually in the lab. But if you want to measure area like that, area, if the room is in that shape of a rectangle, you can use a meter rule to measure the dimensions, and then, but there's no specific common instrument we always use for measuring this, because it depends on also the dimensions of the area you're determining. Next, the quasars not talked. Wes has not said anything. Christabel, have you? Christabel, you go to the next one. Uh-huh. Kyle, you finish for us the next two. Kyle, finish for.
Wait. Name of unit, Newton. Abbreviation, capital N. And the instrument is a spring balance. The last one is volume. The name of the unit is cubic meter. Abbreviation, M to the power 3. And the instrument is a measuring cylinder.
Yes. So the last one there, I mean the last one there is density. We have density, which is our last quantity we have there. So the unit is kilogram per cubic meter. The kilogram there is to be with a small letter, not capital. And the unit there is correct. Density, in measurement of density, we do not use a specific instrument. So as we shall look at the topic, we shall see how can we, the density as a topic, we shall be able to see how we measure it. Those ones, we shall be able to cover them. Now, we now have known from here what estimation is, what measurement is, what fundamental quantities or base quantities are, what derived quantities are. And then we have got to somehow understand what these SI units are, because we say these are now the standard units which are international accepted. It doesn't mean that we only have the specific, these standard units are the ones that we only use for measuring. Doesn't mean these are the only units that we use for measuring the physical quantities. We have others. We have other units that you can use for measure those physical quantities, but those ones are now not called the SI units. So a physical quantity has only one standard unit, standard scientifically accepted international unit for measuring it. So we shall be looking at those ones in details. Then I'm going to, after this, drop for you some work to do on what we have looked at. I will expect you to respond to that work. So it is on what we have looked at, and then I'll actually give two, probably there are going to be two activities. One will be on what we have just done. The next one is going to be on the next unit, or I mean on the next area that we're going to. I think we're moving towards now measurements of the physical quantities. We shall start with length. So I encourage that those who have just accessed, you move to continue studying or moving on with the course. Don't only join us for the lessons here when it is, I mean, don't only expect much when we are for lessons like this. We actually come in here now to harmonize what you have learned, what you don't understand. Actually, at such a time, I'm supposed to be taking maybe questions from you on what you don't understand from the work you have there. But though we shall be mostly moving this way. Thank you for participation. Christabel, you had a lot of issues of network, I think, but I think that the recording will be shared. Then the areas that you don't get well, you didn't get well, you can still get to me. See, you can still have a chat on the WhatsApp group there, or else on what you don't understand, I see how I can be able to help you. I already even have, we have already your contacts. We shall be even able to help some of you that way. So where you don't understand, we shall be able to reach you in any way that where we can be able to help. Here, if the network disturbs, we shall be able to help you. Is that okay? So when you don't understand some concept or some part, feel free to reach us. Thank you for your participation. Kai, thanks for helping us when my network will not support.
You're welcome, teacher. Should I stop sharing?
You can stop. And there we shall have to stop. Have a very good afternoon. Mr. Haman, you can end the meeting. I think we're done. Isaac, Christabel, and Kyle, the meeting has actually ended, so we can leave for other